All right, we will go ahead and get started. Good morning, good afternoon, everybody. Welcome to our webinar on React Native with our Application Services Practice Leader, James Bender. James, you want to introduce yourself?
Sure. As John mentioned, my name is James. I run the application services practice here at Inspire. So a lot of building turnkey applications or going into clients and helping out with some of the more high level, high profile needs. Um, and I've been a web developer for a long time, and I'm excited to be here today.
All right, thank you. So my name is John Agnich. I'm the Vice President of Consulting Delivery here at Inspire Solutions. I lead a team of industry experts across all the practice areas. And James, if you could advance that slide. So you can see kind of a high level of our practice areas there to the right. So I lead a team of industry experts delivering solutions across all of those practice areas. The way we engage with clients, so anything from individual consultants to join your team and help out where needed, all the way up through full project delivery and managed services. So for folks that don't know much about Inspire Solutions, we are a national expert in delivering flexible technology and talent solutions. We have a national presence with now over 13 offices and continuing to grow. I actually sit there in Nashville. Nashville is our National Technology Delivery Center, where we have a big team delivering projects here in Nashville. So that's a little bit about us, a little bit about me. So about the presentation here today, if you have questions as we go through this, there's a Q&A part in the meeting on the right, so you can go ahead and add your question. We'll keep an eye on those. If it makes sense to answer the question throughout the presentation, we'll go ahead and answer that, but likely we'll answer that at the end. So with that, I think we're ready to go. James, you want to take it away?
Sure. So before we get too deeply into this, I just kind of want to set the stage for what this talk is. We're going to discuss hybrid mobile applications. We're going to go over some of the history, how we got to where we are today, and how they fit in with your profile. And then I'm going to talk a little bit about React Native and how we use that in our application services practice to build mobile applications. Some things you're going to have to think about when you move there. We're not going to get heavy into coding. This is not going to be a live coding example or how to write React Native applications on that level. If that's something you're interested in, let us know. We will look into putting something like that together. But what I want to talk about today is, again, this idea that I'm James and I'm a web developer. And I started with ASP.NET. Nowadays, I'm working with mostly JavaScript-based frameworks, React and Next.js being the primary one. And it's been great as a web developer because when those frameworks like ASP.NET I mentioned kind of came into their own, we were able to build a lot of these really great business-based web applications. Before that, it was a lot of kind of client-side MSI installer type of things, which had a lot of issues. But now with the web, we were able to deliver 99% of that functionality without having to worry about any of those issues in terms of deployment. And web apps kind of ruled the roost for a long time until this happened. iOS, iPhone, the first iPhone shipped. And the mobile landscape before that was a lot different. And we had this idea of flip phones. I don't know if you knew enough to have the old Razor phone where you could text on the 9-digit keypad, or if you had a BlackBerry, that was really awesome. But again, BlackBerry really more of an email device than a mobile platform or a mobile application platform. And then Windows Phone. And Windows Phone was kind of a weird novelty. Microsoft took this desktop operating system and basically tried to just make it work on a mobile device. And there's a lot of issues with that. The screen isn't the same, the responsiveness isn't the same, the horsepower isn't the same. And they tried to port a lot of Office applications over that, and they sort of worked, but there were always issues with them. And so the mobile computing was really, again, more just a novelty, and it was expensive to get into and all those other things. It was really just kind of stagnant and didn't look like it was going anywhere. It was sort of, yeah, that's cool, but is it really worth my time? iPhone came out, changed everything. For one thing, they acknowledged the fact that this is not a desktop, this is a phone, and it needs to be treated differently. And they took that all the way down to the operating system level. And if you remember when the first iPhone launched, they weren't really big on apps. It was like, well, build a mobile website and you can run it on the phone. But they kind of realized after a while that it was maybe not the best approach. And so they really embraced this idea of building applications. it gave users a better experience on the phone. And then obviously Android followed suit. Android came out shortly after, alternative to iOS. So apps really became the thing on the mobile device. Sorry. Okay, there we go. So as a web developer, obviously I wanted to get in on some of this, right? But I'm not I'm not an Objective-C person. If you've ever worked with Objective-C, it wasn't a great language. We'll talk about that a little bit later. But as a web developer, I thought, well, I can do this. Again, as a mobile website, I can still deliver that 80% business value proposition. And a lot of that partially was because even at this stage, apps were kind of primitive. They didn't do a lot. It was kind of forms over data or just crazy things like you could pretend, oh, I'm drinking a beer on my iPhone, which again, not particularly useful, but there were limitations even to the application platform. So what we did as kind of our approach initially was we got this idea of responsive web applications, or mobile-friendly web applications is probably a more descriptive way to describe it, where, okay, I can take my web page and make it look better on a phone. I can realize I'm on a smaller device, I can rearrange some things, and I can make a really good mobile experience on my web page. And that was initially what Apple wanted people to do, but again, they realized this isn't really what we're getting. We want to go with the idea of applications. And this worked for a while. And then kind of the next step was this idea of progressive web applications. And what this basically did was took this idea of, well, what if I took my web page and I added a few more things. So I added a manifest file and I created these things called worker threads. You can go in the background. And I made it so that you could essentially download my web application and have it run on your phone as an application. The idea being, of course, this claim, you're going to hear this claim a lot, exactly the same as a native application. No difference whatsoever. That's debatable. And that was a really cool idea. And it was a really interesting idea. And progressive web apps have a lot of going for them. Their big issue was and continues to be vendor buy-in. And there's one particular vendor who's not real hot on PWAs. I'm not going to say the name. I think you can figure out who I'm talking about. And they put up a lot of hurdles in their web browser to kind of hamstring these progressive web apps and make them very difficult to use. And that's really been the big stumbling block, not the idea of a PWA, not the technology of PWA, just the vendor idea. So that has kind of been an issue going forward. And for a long time, this is kind of where things were stuck. We had mobile apps and we had websites. But somebody asked the question, what if? What if I could somehow take this idea of a PWA, meaning I can package my application up as JavaScript, HTML, CSS, whatever, and without using a PWA, which is problematic, what if I could deploy this as a mobile app? And his friends probably said he was nuts, crazy, why do we even hang out with you? It was a kind of a pie in the sky idea. But then something interesting happened. For those of you who are in the .NET world, you might have heard of Mono. You probably have heard of Mono. It was created by a guy named Michele de Casa, and it kind of passed through several different hands until eventually it ended up at Microsoft. And this idea, and keep in mind, this is decades before .NET Core was even thought of. Miguel thought, well, .NET is a great development environment. It's very efficient. I can build applications very quickly on it, but it only runs on Windows. What if I could take this and make this run on other things like Linux and Mac and whatever? And that's essentially how the Mono project was born. And it went through a couple different changes of hands, and eventually it ended up at Microsoft and got rolled into the Xamarin team and into the Xamarin product. That's the X logo over here. And if you're not a .NET developer, what Xamarin essentially is a framework or a tool set, depending on who you ask, that allows you to use .NET, C#, VB, F# for those of for the three people doing F#, to write a mobile application that'll run on iOS or Android. At least that's the theory. And not to be left out, some of the JavaScript and web people thought, well, hey, let's come up with our own framework. At the time Xamarin came out, Visual Studio wasn't free. Microsoft had a little bit of a financial barrier to entry to do .NET development, and Xamarin was no exception. So this idea of PhoneGap came out, and PhoneGap was developed by Adobe, and it was not a open source library initially. It was a commercial library, and at some point that forked off into Apache Cordova. And the history behind PhoneGap and Cordova gets a little convoluted. They split off, and then ideally they were supposed to kind of be the same thing, but they sort of continued to diverge. And certain things that worked on PhoneGap didn't work on Cordova, and vice versa. And the logic and the licensing around these got a little kind of sketchy. I believe at one point PhoneGap had, well, we're not open source, but we have an MIT license. It's like, well, then you're open source, right? And that's kind of how this works. And it got a little hectic. And but we had these tools now, so as developers, web developers, .NET developers, whatever, we could go out and we can start writing these awesome native mobile apps, right? Well, not so much. Turns out there were a lot of issues with these. The first one being they generated really inconsistent UIs. There was no unified platform or unified framework to say this is how a button looks on Android and iOS, and this is how you get there from Xamarin or from PhoneGap/Cordova. So you ended up with a lot of different applications. Like you get an iOS application that would just have these weird looking buttons and weird looking text and labels. It didn't feel like an iOS application. You also had a lack of features. There's capabilities in every device. And if you're writing a native app, you have access to most of those APIs through some kind of toolkit or package. Xamarin, Cordova, PhoneGap, they were somewhat limited into what you could get to. They got better as time went on, but initially they were really limited as to what you could access on the phone. Can you access the camera, the accelerometer, GPS location, all those kinds of things? It was kind of hit or miss what you could get to. There was a bad developer experience, particularly I'm going to say on the PhoneGap Cordova side. Again, they were similar libraries, but they were just different enough. And a lot of developers struggled with, well, when do I use PhoneGap and when do I use Cordova and what are the strengths of one versus the other? And then getting that environment set up to run either one of them was really tricky and it caused a lot of heartache and concerns. And Xamarin had issues too. Xamarin started with good intentions, but you started getting these weird situations where you'd have to have specific code for iOS and specific code for Android. And so your code base would just kind of get this weird bloat, and you'd essentially end up with two code bases anyway, one for iOS, one for Android. And again, there were a lot of issues in getting those to transpile correctly and translate to native applications. Then finally, poor performance. At their core, these are all abstraction layers on top of an OS. Or actually, it's worse than that. They're abstraction layers on top of an abstraction layer on top of the OS. So when you go through all of those abstraction layers, you're going to get some degradation. Particularly in the case of PhoneGap and Cordova, they were open source, so there was really no big money behind them. So their their abstraction layers never really got the love and attention they needed to get better. And at the end of the day, what you ended up with a lot of these was an application that really felt like a mediocre web application running in a very underpowered web sandbox. And that's essentially what you got. We had a lot of, and this is in a former company I used to work for, we built several of these because the time and the budget arguments were compelling, right? I have one code base and I get both apps and it doesn't take as long and I have to hire expensive Java or Objective-C or whatever developer. The problem is the final output, no matter how much effort, how much time we spent, was never great. And in almost every case, the client came back to us in about 12 to 18 months and said, look, I know we said money, time, and all that, but the fact of the matter is our customers hate this application. It just doesn't work. It's a pain. It's slow. It breaks all the time. It's just not what we want. And we would usually end up having to go back and rewrite that application in a native framework. For iOS, Objective-C or Swift, which came out later. For Java or Kotlin, which came out later. Swift and Kotlin are kind of abstractions on those other languages to make it a little bit easier. For those of you who have ever done Objective-C or C programming, Apple, when we got to .NET and Java, we thought we left behind this idea of having to manage our own memory. Objective-C brought that all back. So good job, Apple. Malloc, demalloc for life, I guess. And that was a rule that I had for a long time on my development teams was don't even talk to me about hybrid. It's going to be a disaster. The client's going to hate it. Let's just skip to the end where they ask us to write it in the native language and be done with it and deliver a better product. Don't charge them, or they have to spend the money for that kind of poor quality product up front. We just skip to the part where they're happy and everybody's happy. But those native tools and those native languages aren't ideal. They're complex. I mentioned Objective-C. Objective-C is a great language if you already know C or C++. There's a lot of things in those languages that we don't have to worry about today because they've been abstracted away. Again, things like memory management or pointers, things like that. Well, Objective-C brought those all back. Swift was a way to address that, and it did a good job. But that also drove up the price. Experienced C and Objective-C programmers wanted more money, and they could get it because, well, who else is going to write your app? So it became very expensive to bring these developers in. It also became a problem because you ended up with two code bases, right? You'd have your iOS code base and your Android code base, and neither of the two should meet. So you almost have two development projects. You have to really try to keep feature fidelity between the two of them, which can end up being very difficult. And the way we tried to solve this, in a lot of cases, we said, well, we'll just treat that native app as a presentation layer, and we'll try to do all the heavy lifting offsite somewhere in a web service somewhere. We say the cloud, but it wasn't that grandiose. It's just a web service. And we'll treat that as a sort of presentation layer. And that fixes the problem of divergent code bases, but now you trade one problem for another because those calls up to web services are expensive. They are slow. They take some time, especially if you're on a less than amazing cell network. And so you just reintroduce the problem of poor performance. You've just instead moved it off to the cloud. So these weren't great either. So as someone who is a consultant and who builds these applications, custom applications for a living, I really couldn't get past this idea of wanting this hybrid framework to work. If I could have one framework that could reliably generate iOS and Android applications for me and worked every time and was relatively inexpensive, and better yet, even better, use a language or technology that I already knew, that would solve a lot of problems for me. And a lot of people felt this way too. And so in 2015, Meta, Facebook, who controls React, released React Native. And basically the value proposition behind React Native was you can build iOS and Android applications in React. This was huge because React is inarguably the most popular JavaScript application framework today. Angular, Vue, they're distant second and third. React is the one. So there's plenty of React developers out there. There's plenty of React resources. So this helps me leverage the knowledge I already have as a React developer, and I have this team of React developers who are also now mobile application developers. So I can build these applications the way I need to. It solves a lot of problems for me because I don't have to have the two applications. I don't have to have the expense of talent, and it makes it a lot easier to work with my team because now everybody can kind of be a web developer. So we can move people around and put them whatever role they need to be. So everything was amazing and awesome, right? No, there were still some issues. Like version 1 of anything, there's going to be problems. It did solve a lot of issues. For one thing, it helped a little bit with the inconsistent UI. React did introduce this idea of having a component that could be essentially a component in my React application, but an Android or an iOS appropriate component. It also kind of took care of the lack of features and the poor performance. And the reason I kind of bundle those together is because those are both part of that abstraction layer. The abstraction layer controls what features you can get to, and it controls that performance. And I think one of the benefits that React Native had was being backed by Meta. They had the money to put into it to actually professionally manage that abstraction layer and ensure that it was being built correctly and that it was able to provide all the features that were necessary. So they had the benefit of backing of money. So React Native did solve a lot of problems out of the gate, but you still had this bad developer experience. It was a nightmare to get the development environment set up. It was a nightmare to get the applications built. If you didn't have a Mac, you weren't building iOS applications. You just weren't. That was a requirement. And so the output is great, but getting there is a real nightmare. And React Native needed something to come along to help it get to the next level. And that something was a product called Expo. Expo is a framework that essentially adds on to React. I mentioned earlier, I'm a React Next.js developer. Next.js is a meta framework of React. It adds sort of some of those pieces that React doesn't ship with out of the box, things like a router. Before React did server-side, Next would allow you to do server-side, things like that. Expo is essentially the same thing, but for React Native, in that it provides some of those missing pieces developers needed to build these applications. The big one for me out of the chute was it helps me get those development environments set up quickly. Expo just does it. It just magic wand, boom, you're ready to go. Most of the time. There are some times you're going to have to make some tweaks, but again, it's gotten a lot better over the years. And the other thing I like, and I'll talk about this in a second, is that it makes it just easier to develop these applications more like their web apps than native apps. And I'll explain in a minute why I say that and why it's important. And it offers most of the iOS and Android APIs that maybe React Native was missing. So things like camera, location, authentication, push notifications, other things. They're a lot easier to use in iOS and Android. And the other thing Expo did was allowed me to use what are called native modules. And essentially what a native module is it's a little library or chunk of code that's written in Objective-C or Swift or Kotlin or Java native to that platform. And it can get the things that maybe this abstraction can't. And what that enables me to do is say, well, I don't have a direct link to that from Expo or React Native, but Expo allows me to use this native module to get there. So I have to create a bridge. There is a performance penalty for that. And to be honest, the need for those native modules has gone down a lot. Most of that stuff is available in Expo now, but if you ever did need that, it's available. So how does Expo work? Essentially what you do is you write your React Native code and you'll bring in some Expo libraries, and there's an Expo library for every need practically. And then it does with an EAS Expo build. And then this is one of the sort of myths I want to dispel, is this idea that Expo somehow turns your code into Objective-C and Java and it goes from there. That is not what happens. There's no transmutation of code. There's nothing that happens there. It basically builds these things into a bunch of binaries. So it takes your HTML, your CSS, and your JavaScript, and essentially builds them into binaries that run on top of the Expo/React Native abstraction, which again is an optimized abstraction. So that abstraction idea starts to become a little less scary. The other thing EAS did is it streamlined, I'm going to use streamlined, especially in the case of Google, the application process or the submission process to the app stores. So you can do a lot of the submission stuff from Expo. It just automatically does it. Whereas in the old days, there was a lot of issues getting those binaries uploaded to the sites and deployed and everything else. Expo takes care of that. Now, I will say, of these two, the Apple App Store and the Android App Store, the Apple App Store is very easy to deploy to. The Google App Store is a little challenging. My joke is like it's always a simple 82-step process to get your app deployed there. But the good news is Google have changed it in the past 2 weeks, which isn't really good news, it's bad news. So you'll always kind of have an interesting, fun challenge in getting your Google apps deployed. It's not all that bad, but it is a little bit more complicated than deploying to the App Store. But the good news is Expo takes care of most of that heavy lifting for you, so you don't even really need to worry about it. The other big win for me for Expo is I mentioned it makes it more like developing a web application. So if you've done web application development, be it React, Angular, Vue, you have this idea of a hot reload, meaning I have my development server running in a console and I have my app running over here. And when I make a change in the app, I change the HTML, the CSS, the JavaScript, whatever, my server is recognizing that change, integrating it into my app, and my browser automatically updates with my change. I don't have to go back and recompile, relink, reload, do that whole big thing. If you've ever written client-side or desktop code with .NET, debugger on, debugger off, things like that, you know what I'm talking about, or even native apps in iOS or Android, if I make a change, I have to stop, recompile, redeploy to either my device or to my emulator, and then I can test it, which makes testing things, building things just a lot longer and more tedious. Whereas now I can just make that change and boom, it appears right away. That for me is a huge win. The other thing that I think is generally just a big win for Expo, and I think this is kind of a little bit of a killer app for them, is this idea of over-the-air deployments. Now, if I have a native app and I have a bug, the way I deploy that app is I build it, I recompile it, I rev the version, and then I go through the App Store submission process, which means somebody at Apple needs to review it, which means that could take a day. Or actually, Apple had an outage recently, and those reviews were taking 2 or 3 days to go through it because they had somebody to catch up on. But I'm basically at the mercy of Apple to bless this before I can send it out. Google, same thing, but again, their process is a lot more streamlined as far as approval. With OTP, over the air, what I can do is I can deploy certain fixes to my application without having to go through the Apple or Google Play stores. So this is a great benefit because you probably had an app on your phone that had some small bug. Some really, it could be anything from a label being misspelled, to just a small calculation not working right or a weird UI thing that's happening. And you're thinking, why don't they fix this? This is an easy fix. Why am I sitting waiting for this? Well, it's not that that bug isn't easy to fix. It's that they got to go through the whole deployment process again to push that fix out. So they're going to wait until they have several things that they can send. Because again, that deployment process, it's not overly expensive. It doesn't take a ton of time, but every major company is going to have some kind of change control process. So they have to go through all of that before they can ship it out. With the over-the-air changes, I can push certain changes to my application without having to go through all that. So for example, if I have a small bug fix, I can go ahead and just do that over the air. It just automatically beams to the app. I don't need to go through the app store. Now, there are certain things I can do and can't do. For example, I said bug fixes. So if I'm making changes to my underlying JavaScript, if I am changing content, like if I have, for example, if I have background image in my app, well, now it's spring, I want a happier image. Okay, I can swap that out. Any sort of configuration changes I can make, I can push through the over the air. I don't have to go through the app store. Now, again, these are smaller changes. These aren't intended to be massive version revs because there are certain things I can't do. If I want to add new assets, I can't do that. If I want to change the app metadata, the name, the logo, whatever, I can't do that as an over the air. If I am going to change any of the native modules I mentioned, I can't do that over the air. And lastly, if I'm doing anything that's going to change how the app behaves in terms of policies or guidelines of the App Store, I have to go through the App Store as well. But most of my bugs, it's an 80-20 thing. Most of my bugs are going to be in that list of small things that I can just push and I don't have to worry about the App Store taking forever, rejecting it, whatever. I can just hit it and it goes. That is, to me, huge. And I'm not sure why more people don't use it just for that feature alone. It makes deploying these bug fixes super fast, super easy. Now, there are some limitations to Expo when you bring it in. It is not required to do React Native. However, 99% of the documentation you're going to find about React Native is use Expo. And if you say, I don't want to use Expo, well, why don't you want to use Expo? Expo is great. But there are some limitations to it. I mentioned native modules. They're not all compatible with Expo. There are some that don't work. But again, as Expo continues to grow, its reliance on these native modules starts to go down. So it becomes less and less of a problem every time they ship a new version of it. You are shipping an abstraction layer with an application. So as a result, you are going to have a larger application size. Generally speaking, this isn't a problem. We're not talking, a 2 gig application, but it is larger. So we have to think about who you're deploying this to. Is it someone maybe with an older phone that has less memory, less space? You got to keep that in mind. It is going to be a little bit larger. It is not a super high performance framework. It is fine for business applications. In most cases, for simple business application, performance over data, nobody's going to notice any sort of performance lag. We have an application we did for a client that does some very complex data visualizations, and they run perfectly fine. They're smooth, they're great. There are a couple that have an extremely high amount of data volume, but the ones that are more kind of manageable, you would never even know it wasn't a native app. Where you run into problems, I don't know if this is going to affect many of you, is if you're writing a game. Now, if you're writing like a solitaire game, that's one thing that's fine. But if you're writing a game, an action game, or I heard this phrase the other day, Christmas light explosion game, this is not the framework for you. It's just not up to handling that sort of graphic intensity. It might work on the web, but again, once you get into this abstraction layer between yourself and the hardware acceleration, you're going to run into problems. If that is something you really want to do, because somebody usually will also ask me at some point, well, what about Dart and Flex, or I forget what the name is. That framework is more kind of like building for a game engine. It is very UI intensive, and it's not really so much for business. For business application, I don't necessarily care about a lot of advanced animations or again, the Christmas light explosion. I just want form over data. But if I was writing a game, that is something I would definitely look at. The other thing that is, again, just something to keep in mind is you rely on Expo's platform for builds and a lot of other things too. Expo builds your apps in the cloud. This is why you don't need a Mac. I'm going to talk about the second to build an iOS application. And it's great. You can offload that. There are some issues with that, though. You get a certain number of free builds a month, but then they start charging you. And they don't charge you a lot, but there is a cost you have to put into that. So that is something to keep in mind. The other thing, too, is I know some people are a little skeptical of things in the cloud. If you're going to use Expo, that's just sort of the price of admission. You're going to have to do that. People have tried to get Expo builds to run locally. That has always been a little bit of an issue. I've seen people do it, but you get to the point, is the juice worth the squeeze? So that's Expo. So definitely Expo is something you want to do. We have tried writing React Native applications in the past without it. Realized very quickly this is not going the way you want it to go. Immediately brought Expo in, and everything was great. So I want to talk a little bit about the code. For example, there are some things you're going to have to keep in mind when you move from React to React Native. And like I said, I'm not going to get into a code example today. If that's something you want to see, we can definitely talk about that down the road. But it's sold to us as being, well, it's just React. It's just the same React you're writing today, right? Exact same React. You can practically copy paste done. That's not exactly true. If you look at this little snippet of code, and it's a little bit of an older snippet, but you see something that's missing here. Our tags here, our components, aren't kind of the standard semantic HTML. We don't see divs, we don't see Ps, we don't see labels. We don't see a lot of things like that. And so one of the things I always caution developers when you're moving from a web-based development to the mobile app side is, remember, you are not trying to target an HTML DOM. This presentation layer is a little bit different, so you want to make sure that you're kind of thinking that way. And kind of to what I alluded to a minute ago, I don't have divs, I don't have Ps, I don't have buttons, I don't have a lot of these other things I would traditionally have in an HTML component, but I do have view, I do have text, I do have touchable opacity. Why? What's the difference, right? Well, a couple things. Again, we're targeting something slightly different from the DOM, but the other thing that this gives you that's kind of the big thing is, I mentioned the consistency in the UI. I want my iOS app to feel like an iOS app. I want my Android app to feel like an Android app. If I open that app in my iPhone, I want the buttons to look how I expect them to. I want the labels to look how I expect them to. I want the drop downs. If I open up my Android phone, same thing. They're going to be different, but I expect them to be consistent on the platform. What this does is it makes sure that the right component for the right platform is being used. So when you build this in EAS, what's going to happen is your view, your text, your touchable opacity, which is it's what fancy way of saying button, are going to render, okay, I'm building for iOS in this branch, I need to use the iOS version of this. I'm building for Android over here, I need to use the Android version. So that is something you need to keep in mind, is you kind of need to use these more kind of genericized tags and components, because that's what's going to give you that AI consistency. Another thing is styling. Now, this is something where it can be subjective. React Native uses this style components type of styling out of the box. And it's okay. I am not particularly a fan of this approach, however. I think for a couple reasons. For one thing, and I could believe me, I could spend hours telling you about how awesome Tailwind is and how it blows traditional CSS away. But this causes some issues in my mind. For one thing, I don't necessarily like this idea of embedding the different styles in each component. And I know you can pull these out and put them in objects and bring them in that way, but what I find is you get into the same problem you get into with traditional CSS. I have a global CSS file with 800 classes in it. At least 2/3 of them are never being used. They're not named properly. I have body 1, body 1A, body 2. They don't tell me what they do. And you're just really moving the problem from one file to another when you do things like this. The other issue you run into is that this does have a performance hit on it. Oh, again, it's kind of like JSX. JSX has a very, very slight performance hit compared to just native HTML. This does too. So when you start kind of building applications with this, it becomes very hard to manage, and it does create a bit of a performance hit. So just keep in mind the styled approach component has its issues. So how did we solve it? Well, solve is maybe a subjective term here. We're a Tailwind shop. We used to use Bootstrap. About 2-3 years ago, we switched to Tailwind, and it was a revelation. We never looked back. Tailwind just blows Bootstrap away. It's just so much easier to use. It's so much easier to reason through, and it creates a lot smaller payloads for my application. For those who aren't familiar with Tailwind, it's basically a collection of utility CSS classes. I put them in my elements. I can see right away what's happening in my CSS. I don't have to worry about going to find something in a style sheet or a style components section. It's right there. And the great thing about it is I can limit what tags are available. I can create a theme in my Tailwind and say, these are the colors that are allowed. These are the spacings that are allowed. These are the fonts. So I don't have to worry about, developers 3 pages and the red on them is all slightly different. They're limited to what they can use. So for us, Tailwind was a big win. You can use Tailwind and React Native. There's a couple steps you have to go through in the configuration to get it to work, but they're not particularly difficult. And once you get it up and working, it just makes the development so much faster and easier to work with. So we are big believers in Tailwind here. So this is React, right? We have our styles, we have our new components that aren't HTML components. This is just like writing a web application, right? Well, no. That technology aside, there's a few things you need to keep in mind when you're building a mobile application, be it in React Native, Objective-C, Swift, Kotlin, whatever. The first thing is the form factor. As web developers, we're used to having a actual screen, a laptop screen, a desktop screen. We're used to a certain size, a certain aspect ratio. We're used to laying things out in a certain way. Forms, generally speaking, 2-3 columns. Go through here. We have all the space up here to display information. We have a lot more options in terms of how we display information because we have a lot more space. We don't have that on the phones. The phones are obviously smaller screen, different form factors. So we have to stop thinking in terms of square and start thinking in terms of rectangle and start thinking in terms of smaller rectangle. So the way you've traditionally designed your forms and your displays or your layouts or whatever, you have to really rethink those and kind of come from an approach of, I need to make this work on a phone, and it's got to be something that is going to be usable in this aspect ratio. Now, if you're already building your websites to be mobile friendly, you've got a good head start here because a lot of the same rules are going to apply. But I have seen developers try to take that 2x3 column form with a bunch of stuff at the bottom and cram it onto this little screen and say, well, we'll just make them use it in landscape, which doesn't fix the problem because, okay, landscape's like this big. So just keep that in mind. You have a different form factor, a different screen you're designing for when you build these applications. The other part of that too is you got to think about how people are going to interact with this, right? Again, web developers, mouse, keyboard, what else do you need, right? You can take on the world. That's not how people work with phones. They're going to touch it. They're going to put their fingers all over it and try to pull things down, move things. There are certain things that we're used to having access to as web developers that we can't really use on a phone. Hover's one. Drag and drop is another one. Those things just don't translate well to a touchable device. So we have to think about that. How is the user going to react with that? We don't want to make sure, we want to make sure when we're building these forms, we're not putting things so close together so when you hit one, you're actually hitting the two around it. You want to make sure you're leaving space for that. You want to make sure that your navigation makes sense. So you have it at the top or the bottom. You want to make sure those buttons are appropriately sized again so that customers or client users can hit them. Ideally, you want to make it so that a user can hold a phone in their hand and just use their thumb to get to what they need to. I then don't necessarily have to do a lot of this. So you got to think about those interactions, about things like that. Double clicking is probably not going to be an option. Click and hold is something you can work on, but you got to think about how they're going to interact with it going forward because it's going to be drastically different from the web app. So just kind of keep that in mind when you're laying out. Space is a big thing. That's one mistake I see a lot of rookies make is they think, well, I can fit, I have this phone, I can fit this phone. I can fit 12 labels on here. No, because they're going to be really tiny. When I go to hit one, I'm going to miss it and I'm going to click the other thing. So just keep that in mind. And again, when you're building these out, test them yourself and make sure that it makes sense to you. The other thing we don't really think about on desktop is power. We are generally plugged into a wall and we have all the power in the world. We don't care, right? It's nothing we generally think about. On this, I have a battery. You get the idea. Unless you're one of those people I see walking around where you have a phone in one hand and a battery in the other and you have them connected and it's like some weird kind of high-tech nunchucks or something. I don't know. You have limited power and a lot of the things you do on the phone cost energy. Let me rephrase that. Everything you do on the phone costs energy. So if you are doing a lot of those kind of high-end graphics, that's going to eat more battery life. If you're doing we had an application we inherited and they were doing, instead of doing a refresh or a push, they were querying a web service 4 times a second. And they didn't understand why it was killing the battery. Well, you're querying a web service 4 times a second. Things like that. Think about how you can kind of minimize that power. The other thing to keep in mind is applications on phones have 2 states, when they're up front and when they're in the background, essentially. When you're in the background, make sure your app knows that and make sure any sort of high power things it's doing, things that take up the processor, things that are going to drain the battery, put those to sleep or put them on a longer loop. You don't need to do it 4 times a second, maybe do it once every 15 minutes. But you want to kind of be a good citizen with the other apps and make sure you're not just killing that battery. Because again, even every phone comes out, brand new battery, and then 2 years later, it was like, oh, my battery life's terrible on this. I don't know what happened. So just bear that in mind as well. Now, the next thing we usually get into when we talk to clients about this is this idea of how are we going to test this application? How are we going to run it? So again, using Expo, what you're going to do, generally speaking, is you're going to have this, and this will kind of lead to some other things I want to talk about in terms of trade-offs and things, but you're going to have this console application where you're going to run it, and you're going to get two very interesting things on this console app. You're going to get this QR code, and you're going to get this thing at the bottom, press A for Android, I for iOS simulator. So that's going to give you a couple different ways to test your applications. And the first one I want to talk about is this idea of emulators. Emulators are really cool, or at least I think they're cool because I'm a nerd, but the idea that I can run like a cell phone on my desktop is kind of cool, because back before I had a cool iPhone, I wanted to play some of those games, but I didn't have an iPhone. So I run it in a simulator and download the game on a simulator and sit here and play Candy Crush, which, okay, it's a little sad, but you get the idea. But the emulator is going to run on your machine and basically mimic a phone, and it allows you to do a lot of testing. Now, the other great thing about these is if you were running an emulator, you can download different profiles for phones. I mean, there's 5 or 6 different versions of iPhone. There's a couple 100 million versions of Android floating around out there. So you can download whatever one you want to target and test it on there. Different aspect ratios, different screen sizes, things like that. And you should, because you want to make sure that you're trying to cover the base between not just the latest and greatest, but also some of the older devices that your customers might be using. So emulators are great for testing to a point. And this is where I usually get another question that pops up. Do I really need a Mac? I have a Mac. When I became a JavaScript developer, somebody came and took my Windows machine and made me start using this. It's how it works, part of the union rules. The answer is no. You don't need a Mac. I have 2 people on my team right now building an amazing React Native application, and they are both on Windows. And they have not had any issues with that. They've managed to get through and get it done. But having a Mac will make certain things about your life easier. As I mentioned, the emulators, that iOS emulator is part of Xcode. Xcode is only available on Macs. So you won't be able to run that on Windows. You'll be able to run the Google Android one all day long. Android will run anywhere, it doesn't care. Xcode only runs on the Mac. So you don't need one. It will make certain aspects of your life better. But then we get into another issue with emulators. Emulators have some problems on and of themselves. First of all, they're essentially, I talked about abstractions. They're essentially virtual machines running on top of your machine. So if you fire up 4 or 5 different emulators, you're just going to see your CPU and your memory just go down to nothing. But even if you have just one, it's not going to get the full attention of the CPU. It's not going to have the ability to just do everything at once. So you're going to get into situations where that emulator is going to be laggy. It's going to be slow. If you have some kind of cool animation in your app, it might be kind of stuttery. And then there's certain things that just don't test well in emulators. Things like push notifications sometimes don't come through because they just can't get through all the different abstraction layers down to the emulator, things like that. There are things in the emulators that are just difficult to test. So you should still have a physical device to test. That QR code I mentioned before in the console app, if I take my phone and I point the camera at that, it will open the app on my phone, provided I'm on the same network. Now, I do need to have the Expo client installed on here, which again is a very small application, but that will put the app on my phone and I can test it here just as if I was testing an emulator, meaning I even get the hot reloads on here, which I think is really cool. So I can test it on my device, even if I don't have an emulator. And this is going to be helpful because, again, it's going to be on a device. So some of those issues I had on the emulator, like the stuttering or the push notifications coming through, those will work on here, even if they don't work in the emulator. So you definitely want to test with the mobile device. Now, I understand most people only have 2 cell phones, but with what I do and I recommend is that you buy at least a couple different, if you can, refurbs. This is my phone. It's an iPhone. I got whatever the latest version was when I bought it. I don't even remember. It's green. That's all I can tell you. This is an Android phone I bought off a site called Back Market. It's refurbed. It's a Samsung. It's probably 100 years old. The battery doesn't work, which is why it's plugged in, because if I unplug it, it'll die in 2 minutes. But I don't care because it'll run my app and I can test it. And it cost me less than $100. So with refurb hardware, you can have the devices you need to test. Granted, the refurb apples are a little more expensive, but you should definitely try to make sure you have at least one of each device to test on them. Don't rely on the emulators. Emulators are great for kind of 80% of the things, but before you ship it, you definitely need to have it tested on a physical device. Okay. All right. So before I go, I want to share a couple success stories we've had. The first one is a regional transmission organization. They work in the energy field. So it's sort of like an energy co-op, but not really. I don't really understand some of their industry, but that's okay. I don't think I need to, because they're a great client and they were very good about explaining things and explaining what they want. They needed an app to do two things. They wanted to send emergency notifications to their clients saying, hey, there's a weather event coming, or there's a power surge, or there's going to be an outage, whatever. They wanted to notify their customers. And they also wanted to provide, this is when I talk about the visualizations. They wanted to really provide some great visualizations to provide people with some of the market data for energy so they could see prices, outages, all kinds of data relating to domestic power or domestic commercial power, I think. And that was charts graphs. They also had maps where they would bring up a map on the phone and they wanted to put pins in it where you could see where different things are happening, different surges, regional surges, things like that. We were able to build that in React Native. And this, again, I talked about some of the UI stuff and the graphical stuff. This really pushed the limits on a lot of that. But we were able to get it built. It works great. And the client's very happy. We delivered it very quickly with iOS and Android. This was actually two different phases of a project. And I think combined, they took about 3 months, 3-person months to get them all done. We had one developer for phase one, 2 developers for phase two. So we were able to deliver this amazing app very quickly with React Native. The client's very happy. The other one is an application where the company owned several smart vending machines. And what the idea was is these vending machines would send a signal up to the cloud. And basically, they wanted to push that signal down to an app of someone who's essentially a dispatcher driving around with these items and the ability to restock these machines. So it needed to know, okay, what are you out of, who has it, and who's close to you. So we built an application that would essentially, now the API in the back end had the catalogs of everything. We would report the inventory up when it was used from the phone, but essentially the API would push down, find the person, where are you? Okay, you three are closer, but you're closer, so I'm going to tell you to go restock this machine. So basically, it was able to go down, know what needed to happen, and also if they needed to empty the cash box. It was able to get these signals from the machine, send it down to the appropriate person who could then go service the machine and report back when they were done. This was another one that was, again, sort of complicated. It didn't have the graphical needs, but again, there was a lot of routing. There was a lot of communication back and forth, making sure those inventories and those statuses were in sync between the dispatcher and what they had and what the machine needed. The staff at the company had a limited IT department, so they were very excited about just having one code base and in a language that their developers already knew. And we have several other projects on the way, so hopefully the next iteration of this talk will have several more of these stories to tell you. They're all going pretty well, and that's kind of where we're at. Before I open the door for questions, I did just want to let you know that if you would like, if you're going to be in the Kansas City area, June 27th or 28th, I will be giving this talk again at the Kansas City Developer Conference, as well as a talk on how to unit test your JavaScript. So if you're in Kansas City and you want to check this out again, or just say hi, or you have a question or whatever, please feel free to stop by. And with that, I'll turn it over to John in the Q&A.
Okay, thanks, James. So for question and answer, we can do this 2 ways. If you want to put it in the chat, we'll respond to that. Or if you want to raise your hand, I'll unmute you. So, all right, we got a question here. All right, Chris.
Hey, Chris Hope, thanks for having me here. I appreciate the talk. It was quite informative. This question was for you, the presenter. I'm just curious, have you had a chance to take a look at the new architecture and the implications that the JSI will have?
So there was an announcement recently. They're changing the architecture behind this. To be honest, I've been so busy prepping for this, I haven't had time to dig into that. I think that announcement just came out last week, didn't it? I have kind of read the bullet points. I'm excited about it. But again, remember what I said about version 1 stuff? It's a little sketchy. I kind of want to let somebody else be the test subject before I go all in on it. We'll play with it. We'll kind of evaluate it. But again, as far as it's exciting if what they say is true, but before I commit a client project to it, I want to see a little more, And then again, I think they're still a couple months away. I think they just open sourced the progress. So
yeah,
they're
no,
not,
absolutely. They're basically just saying, hey, we've been internally using it as well as it's also been opt-in for some time out in the wide world. But that they open source at least the knowledge that we're working towards making this default. And I think the primary difference here is they're doing away with the asynchronous bridge. Basically, they're the interpreter that was saying, hey, you say this in JavaScript and go do this over here in native land. And they're replacing it with something they're calling the GSI or the JavaScript interface. And basically, the main difference is there's no handoff. It's literally somehow through black magic. I'm curious how JavaScript is able to hold a C++ object reference, and you just work with it.
I mean, you said
So,
it's black magic. I'm sure there's something in the
there's a
OS
cost somewhere.
Well, there's something in the OS, and also my understanding is part of this is written in Rust, which opens up other opportunities for you. Rust is another language. It runs on the phone. It's very fast. It's kind of like a C language, but not as painful, I guess would be the best.
So it's a spiritual successor, I'd say, to C.
Yeah. Yes. But again, less icky pain and more awesome code.
Sure. There. Thank you. I was just curious what your thoughts were. Good.
We're still exciting if true, I think would be the best way to describe it.
Cautiously optimistic on my end as well. I tend to like to say, okay, let's get to an actual GA and let the dust settle, and then we'll see about that.
And you got to keep in mind, this is from Meta, and they thought those goofy AI glasses were going to be awesome too.
They also thought that StyleX would take over Tailwind.
Fair enough. Yeah. All right. Awesome question. Thanks.
Mm-hmm.
Anyone else? You're all still awake, I hope. Okay, Brian.
Okay, you can unmute.
Yeah, I jumped in about 20 minutes in, but I wanted to see if you guys had touched base on or discussed anything about the mixed reality programming abilities.
So I didn't. Again, this was kind of more of a business-based overview. And again, kind of the mixed reality thing is, it's nice. I don't know any of our clients who are really looking for that. And again, to me, it looks a little, I mean, I think there's a use case for it, but I don't know that it's going to be something that any of our clients are in. It strikes me a little bit as being a problem looking for a solution. I hope it finds it one day, because I think it's a cool idea. Or sorry, a solution looking for a problem. I had that backwards. You know what I mean? Well, I hope it finds it because I think it's a very cool idea. Sorry, go ahead.
From the perspective I'm coming from is manufacturing and renewable energy development projects, being able to gain some value in building out applications that allow our corporate support team to be able to support technicians in the field, say tearing apart a pump or taking apart some sort of boiler or something, replacing parts and things like that. A very specific use case there, and I'm looking at developing something for that application.
Right, and see, that would be a great use case for it. And again, it's something we're looking at, or we're familiar with. But again, we just haven't really dug into it yet because we haven't really had a great use case. But the one you described sounds like very interesting. Something we'd definitely be looking at for something like that. If you're interested, we can take a look at that, but we just haven't had that come up yet. Most of the clients we are working with just want to. They're looking at it. The company with the vending machines aside, they're looking at it as just a high-end data consumption tool right now.
Okay. Thank you. Appreciate it.
I mean, obviously we're pushing the boundaries. We love that.
All right. Any other questions? All right, James, I think we're done.
Well, I'd like to thank everybody for coming out. I hope you had a good time, and I hope you learned something. And again, I just really appreciate it.
Thanks, everybody.
Thanks, everyone. Thanks, Chris.